1 minute ago, a drone surfaced from Challenger Deep, and what it recorded has never been captured before. If you think you understand the deep ocean, this discovery will completely shatter everything scientists believed about Earth's final frontier. Right now, while you are watching this video, that drone is transmitting footage of a glowing formation that matches nothing in biological or geological records. We are not talking about fish or vents. We are talking about something building itself at 10,938 meters down. A structure that should not exist. The drone's hull was rated for 1,200 atmospheres. But pressure did not trigger the abort. The light did. Sensors registered thermal signatures that matched nothing in the database. The formation did not behave like minerals or biology. It did not fit a single classification. But when researchers rushed the black box to a secure facility, what they saw raised questions no one was prepared to answer. It was not a mineral deposit. It was not a whale fall. It was not any formation they had ever classified. The composition suggests the trench might be exchanging material with deeper layers in ways current models cannot explain. Here is what is keeping oceanographers awake at night. The Mariana Trench is showing energy signatures that mirror isotope ratios from the late Cretaceous period, right before one of Earth's mass extinction events. The question is not just what this strange formation is, it is whether the deepest point on Earth holds a record of something catastrophic that has been preserved for millions of years. The Mariana Trench is the deepest wound on Earth's surface. For decades, Challenger Deep was considered a solved frontier. Pressure, cold, silence. A place where geology behaves predictably and biology simply stops. Scientists at NOAA have mapped its trenches, measured its temperatures, cataloged its few resilient species. The Hadal Zone is hostile but familiar. In 1960, the Trieste descent proved humans could reach the bottom. Since then, manned and autonomous missions have mapped its features in increasing detail. Autonomous drones have made the journey routine in recent years. Standard calibration runs. Telemetry checks, data packets archived, rarely reviewed in real time. The rhythm was predictable, a cycle of deployment, descent, and retrieval. The drone's hull was rated for 1,200 atmospheres. Its cameras designed for absolute darkness. Its mission was simple: scan, record, return. Nothing more. On March 2025, that familiar, the pattern began to shift. A technician monitoring the acoustic feed noticed something in the sonar return that did not match any geological profile. The signature was structured, dense, but nothing with that density should exist at that depth without crushing under its own weight. For those who know the trench best, the message was clear. Something beneath Challenger Deep was different than expected, and the standard models might need revision. The drone breached 10,000 meters. Its titanium hull groaned under 1,100 atmospheres, welds flexing with each meter of ascent. But the pressure readings held. The cameras were failing. At 10,605 meters, the seafloor was supposed to be empty. Barren basalt. Static sediment. Instead, the forward array captured a glow. Not the dull red of a thermal vent. A sharp, crystalline blue cutting through absolute darkness, emanating from a structure that matched nothing in the database. It wasn't a mineral deposit. It wasn't a whale fall. It wasn't any geological formation they'd documented before. The surface team watched the live feed in silence. The formation appeared to be growing, actively, extending filaments of light through the sediment like veins through tissue. Then the sonar returned an anomaly. The formation was emitting its own acoustic signature, perfectly timed intervals, not random noise, not thermal expansion, a rhythm no one could explain. The pilot initiated emergency ascent. Hull integrity was dropping faster than the climb rate. The external microphone picked up creaking metal, loud enough to drown out the thrusters. At 8,000 meters, the feed flickered. At 6,000 meters, it cut out entirely. When the drone breached the surface, the recovery team hauled it onto the deck with reinforced cables. The hull was intact, but the camera housing had cracked. Seawater poured from the sealed compartment that should have been watertight to 12,000 meters. Inside, the memory module was warm to the touch, hot enough that the chief an engineer used insulated gloves to extract it. The crew downloaded the final frame. The formation had changed position, 3 meters from where it started. The movement could have been sediment shift, or something else. But when technicians reviewed the full seafloor scan, they noticed something that made the movement irrelevant. The formation wasn't sitting on the seafloor. The density reading suggested it extended through the sediment layer into the bedrock below. The memory module arrived at the facility, double sealed in a titanium case. Chain of custody protocol demanded immediate transfer to isolated analysis, but the lead oceanographer pressed for real-time extraction. At 0812, a senior technician in ESD-rated gloves broke the first seal. The moment the case opened, a smell hit the room. Metallic, sharp, wrong for equipment that had been underwater. The technician logged the anomaly and reached for the drive connector. Contact made at 0814. Every screen in the room flickered. Not a power surge, a signal cascade. The audio file began autoplaying before anyone touched a key, and a subsonic tone spilled from the speakers. So low it bypassed hearing entirely, resonating directly in chest cavities and sinuses. 2 analysts staggered back. One dropped to his knees, blood streaming from his nose. The other clawed at his ears, mouth open in a silent scream. Sensors along the wall started reporting impossible readings. The temperature gauge dropped to -18 degrees Celsius in a climate-controlled room. The atmospheric pressure monitor spiked to 800 millibars, then crashed to 200. The numbers contradicted every other measurement, but the system log showed they were coming from the audio file itself. The data was rewriting hardware calibration in real time. The containment officer slammed the emergency cutoff. Steel shutters dropped with a hydraulic scream. Negative pressure engaged, sucking loose papers toward the vents. The drive was sealed behind 3 layers of Faraday shielding. Medical staff rushed in, hauling the bleeding analyst toward the exit while the other sat against the wall, hands still clamped over his ears, rocking. Within minutes, the corrupted systems were offline. Backup servers quarantined. The module sat in isolation, inert and silent. For the team, the message was clear. Whatever data the drone had recorded wasn't just unusual. It was physically incompatible with surface analysis equipment designed to handle the most extreme deep-sea parameters ever recorded. Remote sensing specialists gathered in a makeshift command center, their screens lit with acoustic tomography from the trench floor. The usual patterns of seabed density were gone. Now the instruments mapped a network of void spaces, places where sonar pulses simply vanished into silence. These acoustic gaps, detected through deep water arrays, hinted at unexplained cavities beneath the formation. Theories flew across encrypted channels, collapsed sediment chambers, unexplored mineral pockets, or structures that formed under conditions no longer present on the modern seafloor. A consulting geochemist was brought in to review the isotope readings from water samples collected by the drone's filtration system. She ran the samples through a mass spectrometer 3 times, recalibrating between each pass. The carbon ratios were consistent. They matched signatures from the late Cretaceous period, the same era marked by one of Earth's 5 mass extinctions and global climate disruption. The findings split the analysis team. One group argued the formation was preserving ancient material, a mineralized archive locked in the basalt. The other side pointed to active thermal signatures captured by the drone's sensor array. If the formation was just a fossil record, it should not be generating heat. Then the lead oceanographer found references in the historical database. 1978. A deep-sea survey conducted by a research vessel had detected density anomalies at nearly identical coordinates. The ship's log included a brief notation that read, "Unexplained reflective signatures. Requires follow-up mission pending equipment availability." No follow-up mission was ever logged. The data sat archived in a government facility for nearly 50 years, unexamined until now. Meanwhile, news of the drone's discovery began circulating in academic circles. Within 48 hours, 2 research proposals landed on the desk of NOAA, both requesting priority access to Challenger Deep for follow-up missions. But the proposals were not from universities. They came from private marine resource companies, both citing potential energy applications of deep seabed mineral formations. One company had already filed preliminary seabed survey rights with the International Seabed Authority.
The response was immediate. Environmental coalitions organized demonstrations in Seattle, San Diego, and Miami. Outside the NOAA Pacific headquarters, 400 activists blocked the
people formed a human chain at the entrance. Their sign said, "The abyss is not for sale, and 11 kilometers down, off limits." Chants echoed off the building's glass facade as security officers watched from the lobby, waiting for instructions that never came. Local news crews arrived within the hour. By evening, the footage had gone viral. Scientists found themselves caught between the pressure to share findings and growing public fury over commercial exploitation of a site they barely understood. Online petitions demanding UNESCO World Heritage protection for Challenger Deep gathered 200,000 signatures in 72 hours. The final data packet from the drone's backup sensors added one more complication. The water temperature around the formation was elevated above the baseline for that depth. Not dramatically, but measurably and consistently across multiple thermal probes. The readings suggested localized heating, similar to hydrothermal vent fields. But the nearest known vent system was more than 50 kilometers to the northwest, and thermal plumes do not travel through near freezing deep water without rapid dissipation. Whatever was warming the water was doing it from inside the formation itself. The Mariana Trench has been surveyed dozens of times over the past century, but the 2025 event stands alone. For the first time, a deep-sea drone captured footage and data of a formation that matches no existing geological or biological classification. Lab analysis confirms the material is not standard basalt, sediment, or any familiar deep-sea mineral. Acoustic imaging reveals void spaces beneath the structure, echoing conditions that suggest either collapsed chambers or active material exchange with deeper layers. Isotope analysis shows carbon signatures matching the late Cretaceous period, the same era that marks one of Earth's 5 mass extinctions. Yet as of today, no peer-reviewed publication has classified the formation, and no comprehensive risk assessment has been completed. Research access is complicated by commercial interests and public demands for protection. What is clear? Challenger Deep's behavior is revealing patterns never documented before, drawing urgent attention from researchers and policymakers across multiple continents. A backup drone sits prepped for a second descent, but mission parameters remain classified, pending interagency review. Until more data is released, the true nature and origin of the formation remain unresolved. A stark reminder that even our deepest frontiers, explored for more than 60 years, still hold secrets scientists are only beginning to uncover.